Hello, welcome to ELC Instrumentation. We're doing troubleshooting. This is your final chapter, chapter 13, and unfortunately we haven't been able to troubleshoot as much as we wanted to, but ELC 270 will actually do more of that, so it'll be great for you to get into calibration and troubleshooting in that next course. But I am sad to say we didn't do as much as we should have. Now I want to talk about your role as a process operator and instrument technician. You are the first in the line of defense on working on troubleshooting. You are to be trained to know what needs to be fixed because you know what is working correctly since you've been working with the instruments and the process daily. You're very well known of what the problems are, what maybe temperature effects are, and different seasonal changes may affect your instrumentation. So you've been working with this, so you know. So it is expected that you can troubleshoot the problems and knowing how to figure out whether it is process related or if it's instrument related. When you have a failure, say we look at this chart, the condition of the instrument goes down as we're going along till it basically is not functioning as time goes along. So the failure begins and you try to quickly predict what might be the problem. Then you come in and have a skilled inspection on it. Then you look at it, you try to get the errors and the problems fixed and try to keep yourself running, because we know that if you're down here and you have to go in and break the line open and so on, then that costs money because you have to shut down. So that's important for you to know. But again, troubleshooting to see the potential ramifications of the issue, okay, knowing either shut down or not. What's important to understand is it is at all times you always keep safety first. So you always look at that when you're running. If you have a problem, what is your failure? How does it affect the safety of everybody and the plant? Number one. Secondly, you want to maintain the process to keep running because you know that if you are down, it costs money. Then you shut down. If you have to shut down and you realize you have to remove a valve maybe, then you do that as quickly as possible, again, to get back up on running as quickly as possible. Okay, so your role. Again, you need to be able to report the problem. You may even have to fix it. So each plant runs differently. Some plants will give you more ability to go out and do things, and other plants will not. So you need to know what's important and what your plant will allow you to do versus a mechanic to do the work. And or even you could be the process operator technician, or you could be the instrument technician. You may be able to do both. You may only be able to do one thing. So again, it reveals the importance of process knowledge and troubleshooting. All right. So here are some typical malfunctions when you're looking at your primary sensing elements and your transmitters and possibly your control valves. There's always a potential environmental failure, and this part we're going to go into more detail. You may have an installation incorrectly, so that's something that needs to be looked at. And also remember that these instruments have a life expectancy, so it may be getting near that point. There also may be preventive maintenance that will keep you from having a shortened life expectancy, and also this will help keep calibrations in line. So that's another way to look at that. All right, let's look at the environmental factors. So you have excessive temperatures or sudden changes of temperature. Sometimes in different states, like Texas, you can go to 20-30 degree change in temperature really fast within an hour or so. That does affect your plant. Plus, if you're running with volatile substances, as usually are in a refinery, that could be very dangerous, and you have to see that could stress your tank. And again, we can talk about pressure differences, which could, if you don't have venting properly and so on. Then you can have corrosion, overranging, inclement weather, the high humidity. These two contribute a lot to corrosion and making sure that you have the right materials of construction. You could have high vibration and mechanical damage as well. Now, as we're continuing at this point, right, we've talked about the environmental issues. Now we're just going to talk about each of the types of instrumentation, the sensing elements and all the different parts that go to them and how they have normal problems associated with them, malfunctions. So we're going to talk about them individually. Now again, you may have any of these normal expected type of malfunctions, but then you can always have a really strange one, and then you'll have to troubleshoot that further. You could have plugging or partially plugged tubing in this line here. You could have it leaking. It could be wrong size, right? Then some vibrations could cause these things to come loose. Okay, that could then cause leaking. You can also have heat tracing. If it's too hot or too cold, it could affect this tubing as well. And then mechanical damage. Thermocouples. So the thermocouple itself could burn out. It could be corroded. That's, again, materials of construction, the right materials for the right application. There could be a bad connection. Now remember too, if you have a thermocouple in a thermal well and you don't have a conductive fluid, that could give you some wrong readings. This is an installation issue, so you'd have to look at that as well. You could have a signal wire and the malfunctions associated with that. Poor or bad connection. You could have a broken wire. Maybe too much loop resistance. So we've talked about the equations, right? Voltage is equal to IR. So your current and resistance are related. So you have to look at that. Then you could have shielding problems as well. So remember when we talked about resistance, how long is the wire, how thick it is, things like that. So this can cause a lot of problem with the resistance here. Then we talk about transmitters and malfunctions. So these are all the different types of transmitters you can come into contact with daily. So you could have a low voltage from the power supply, or you might have an instrument air supply problem. You could have a loss of power. So this loss of power we've talked about with the voltage. Remember, your zero starts at 4 milliamps, and an air supply, your zero starts at 3 psi. So if you lose power or you lose air, you'll know that that's more than likely the loss of power and not just an instrument reading low or reading incorrectly. You can have corrosion. Again, excessive humidity helps contribute to corrosion in different areas. And you can also have a calibration shift, and we're going to talk more about that in a little bit. Let's talk about your controllers and your malfunctions. Now, most of the controllers you'll be seeing, if you work with the distributed control system, the DCS, then this is not really going to be a problem. But as we have seen with our PC101 and the Yokogawa controller, this is a physical device, and it may be a physical device that you're working with, some single loop digital controllers. It may also have control more than 1 or 2 loops. Some of them can go up to like 4 loops. Here, you can have plugging. You could have water in the air. Now these should be sealed properly, but again, over time they might just get little cracks, and then their electronics could be messing up a little. You could have a power loss, water in the device itself, air or electrical power failure, and then you may have to retune it, because what happens is, say you change a pressure transmitter or some other transmitter device. What if it's a quicker response? You got a newer model, so then you have to retune your loops. And that's something to just think about. Your final control elements and associated. Here we're showing a control valve. You may also have a solenoid valve. You may have a louvers, we've talked about for the final control element in the furnace. You may also have a variable speed pump. So different final control elements. Here is very obvious to see how you might have process plugging. Even in a pump, if you're using a slurry, a different material, a material that maybe gets thickened or something as it's going along, temperature exposures and so on. So these are areas to look at. You can have corrosion or erosion in the valve itself. The packing could leak, very important to note that. You also may have a valve sticking. And then mechanical failure with the tubing or any of the components. Water in the airline, very bad. Water in the device itself. You could have air or electrical power failure. And then your I to P, your current to your pneumatic signals and or the positioners could be out of calibration. So they have to be looked at as well. Okay. Now, when we're going to look about the troubleshooting in general, it is really an art. It's really commonsensical. And again, knowing how much you know about the process and or your own individual technical knowledge of different mechanical types of things or electrical, or maybe you're just savvy in that area. So all of them contribute to helping you troubleshoot in a better way. Here, the first step you would take would be interpret and analyze. So you want to determine the problem. Is it really an instrument problem, or is it that process-related problem? Evaluate and infer. From this information, you determine maybe a potential solution. Then recognize. Be able to determine if it is an instrument problem again after you've evaluated. Repair. Then fix the problem. Reevaluate. So once you fix that problem, go back to make sure that you did fix it. Maybe you fixed a portion of it, or maybe it really wasn't the problem. So that's what you have to check out. Once you've completed all of these steps, documentation and communication. Make sure that you tell the people in all of the areas that you work with that you did some changes or you changed it, not just for historical purposes or regulatory reasons, but for safety first, because sometimes you just don't communicate that and something dangerous could happen. So you have to let people know. There should be a management of change process anyway, the PSM, Process Safety Management, that takes care of this part of it, documenting and telling everyone about it. Okay, once you have done your gone through some troubleshooting, there are a couple areas we're going to look at. This is specifically looking at the controller. So again, you could have a controller in the DCS, so it's kind of like a software feature, or it could be the actual physical controller as in the Yokogawa on the PC101 trainer. There's also the Honeywell in the other trainer in 132 that we're getting started with. So you make sure your process variable indication on your controller corresponds to the true output of the transmitter. And then again, put it in manual, see if if the process stabilizes. While you're in manual, you can also see if your control element is moving the way it should. If you're changing percentages, is it moving smoothly? Is it doing exactly what it's supposed to do? And then here, you're going to always make sure your loop is properly tuned. Now another really cool tool is called dividing the loop in half. So this is one part of it. So you think about your control loop. You have your sensing elements. It goes to a controller. Then from the output of the controller, you go to your final control element. So you really can see how we could divide this in half. Statistically, one device is going to fail at any given time. It's very rare that you have multiple problems. Very rare. So again, you're just going to be looking for one piece right now. So most of the loops have this, like I said, transmitter controller to the final control element. So we already started at the controller in this last slide, right? So after that, you come to, sorry, I went the wrong way. I'm going too fast. So you start, there's one of three ways to do this. You could look at the problem between the process, which is your sensing and transmitter, to the controller itself, or from the controller to the final control element. So we're going to look at the two ways. If you're looking at the process and to the controller, you check your transmitter's output, maybe you look at your sensor, make sure they're matching. You could check the transmitter 0. Check your process piping and the connections. Check the sensor and calibrate or replace the transmitter. Then go back and check again. Put everything, connect everything, and then go back. If it's not that, to the controller and it's not the controller, check the final control element. Again, this is the second half. So the most common instruments you would look at are the I to P converter, the control valve, maybe there's a positioner. So those are the things you look at in your actuator. So these are the areas, the I to P converter and the control valve. You can just have the controller room operator, technician check it and send outputs, and then that field technician goes out and checks it to see how it's moving. And this should help you with the process. Okay. Communication is very critical whenever you're working on troubleshooting. You always work with it as a team. And you use two-way radios because we know that they're the great instrumentation, because we want to keep instruments that are not flammable or cause sparks or anything like that. And the two-way radios work really well. Get your signals down. You'll have been working with each other probably for quite a while, so you'll know how to communicate well through these. Now the tools that you want to use. You always use the right tool for the right application, for the right job. So we have a Phillips head here. You could have an adjustable wrench. The multimeter tool, we've used this in our labs. Very, very good piece of instrumentation to use, or tool. Here you have maybe temperature or pressure gauges, testing gauges, and your two-way radio. Remember, safety first. You may have to get a lockout tagout. You may have to do some permitting, depending on your job. You may need a cold permit. You may need a hot work permit. Okay, very critical. Make sure you go through your steps and do the right types of permitting in order to get to what you need to. Now let's talk about calibration and troubleshooting. Over time, your instrument can vary from its original calibrated ranges. It's important to know. They may require calibrating it periodically. This is what we talk about here when we talk about a preventive maintenance schedule. So you look at the calibration of the instrument and you just go through that. So the instrument should be calibrated according to a regular schedule, okay, and preventive maintenance schedule. So it's important to do those as well. Okay, and remember, safety first. Next, we'll just talk shortly about troubleshooting smart instruments. This is what you're going to be exposed to a lot. There are microprocessors in there. They have diagnostic capabilities. And a lot of the data can be stored in these processors. Sometimes you can go back and find exactly where the error occurred. And it makes it a lot easier for technicians when you're troubleshooting. So smart calibrators will be something you'll be seeing a lot more of in one of the areas that we were just learning and working with. Okay, well, this is it. The last week of your studies. So do your homeworks. You have a final, open book final. And also, don't forget your lab and working on giving me instrumentation and the specifications for a specific process called the flash tank. Please let me know if you have any questions, all right? You have a great week, and I'll talk to you soon.